When people say that a mirror reverses left and right, they are describing a feeling, not a physical action. The mirror itself performs a far simpler and far more precise operation. It reverses depth. What was in front of the mirror is now behind it, and what was behind is now in front. This single flip along the front-back direction is the only transformation a flat mirror ever makes. Everything else we believe about left and right is added later by the human mind. To understand this clearly, imagine a single point in space hovering in front of a mirror. That point has a position. It is some distance in front of the glass, some distance to the left or right of the center, and some distance up or down from the floor. When the mirror reflects that point, the up-down position does not change, the left-right position does not change, but the distance from the mirror does. The reflected point appears the same distance behind the mirror as the real point is in front of it. Physics stops there. No swapping of sides occurs. The mirror has no concept of left or right. It only responds to how light travels. Light rays leave the point, strike the mirror, and bounce back following a strict geometric rule. The angle of incidence equals the angle of reflection. Because of this rule, your eyes interpret the reflected rays as if they originated from behind the mirror. That imagined origin is what we call the mirror image. The geometry does not twist, rotate, or rearrange the scene. It simply inverts depth. The mirror image is a perfect front-back reversal of the original world. If mirrors truly reversed left and right, written text would behave very differently. Consider the word ambulance, written on the front of emergency vehicles. It appears reversed in a mirror so drivers can read it correctly. But notice something subtle. The letters themselves are not flipped top to bottom. The A is still upright. The word is reversed because the entire object has been turned around in depth, not because the mirror singled out left and right as special directions. The mirror shows the back, facing version of the word, exactly as physics predicts. The confusion begins when humans try to interpret the mirror image as a person like themselves. When you look into a mirror, you do not think, "I am seeing a front-back reversed version of the world." Instead, you instinctively imagine another person standing where the image appears to be. You mentally place yourself behind the mirror and ask, "Which side would my left hand be on if I were standing there?" That mental act involves rotation, and rotation is where left and right get swapped. To see this more clearly, imagine meeting another person face to face. Their left hand is opposite your right hand, but this is not because the universe has reversed left and right between you. It is because the other person has rotated 180 degrees relative to your orientation. You are facing each other. Rotation swaps left and right while leaving up and down unchanged. This is exactly the rotation your brain performs when it compares itself to the mirror image. The mirror does not rotate anything. You do. You imagine turning yourself around to match the orientation of the image. In doing so, you introduce a left-right swap that did not exist in the reflection itself. The mirror image is not facing you in the same sense that another person is. It is facing the same direction you are, but with depth reversed. This subtle difference is easy to miss, and our brains gloss over it automatically. Up and down provide a useful contrast. When you look in a mirror, your head stays at the top and your feet stay at the bottom. Nobody asks why mirrors do not reverse up and down, because gravity anchors those directions firmly in our experience. Up is away from Earth, down is toward it. We do not mentally rotate ourselves upside down when we look into a mirror, so no up-down reversal is introduced. Left and right, however, are not anchored in the same absolute way. They depend on which way you are facing. If humans naturally rotated around a horizontal axis instead of a vertical one, mirrors would appear to reverse up and down instead of left and right. The mirror would not have changed at all. Only our habitual way of imagining ourselves would be different. This shows that the perceived left-right reversal is not a property of the mirror, but a property of human psychology and body symmetry. Richard Feynman emphasized this point because it reveals a broader lesson about how easily intuition can mislead us. We trust our everyday language phrases like the mirror flips left and right, without questioning what they really mean. But physics is not concerned with linguistic shortcuts. It cares about transformations, coordinates, and measurable changes. From that perspective, the mirror performs one transformation and one only. It changes the sign of the front-back coordinate. Consider a simple coordinate system. Let front-back be the x-axis, left-right be the y-axis, and up-down be the z-axis. A flat mirror placed vertically reverses the x-coordinate and leaves y and z unchanged. That is the entire mathematical description. There is no operation acting on left or right at all. The idea that left and right are special directions is something we impose after the fact. This becomes even clearer if you imagine non-human observers. A creature with a radically different body plan might not experience the mirror illusion at all. If a being had perfect symmetry in all directions, or no strong distinction between front and back, the mirror's effect would not produce the familiar confusion. The illusion depends on how human bodies are shaped and how human brains are trained to recognize faces, hands, and orientation. Even language contributes to the misunderstanding. We name left and right hands differently, but we do not name front and back hands because we only have one of each. When the mirror shows us our other hand, we instinctively label it as the opposite of what we expect. But what we are really seeing is the same hand, viewed from the opposite direction in depth. The label changes, not the physics. The mirror also exposes how strongly we rely on imagined motion to interpret static images. The reflection is motionless, yet our brains act as if a swap has occurred. We imagine crossing into the mirror, turning around, and becoming the image. That imagined journey includes a rotation, and that rotation is responsible for the apparent left-right reversal. The mirror itself never performs this step. Once you recognize this, the mirror stops being mysterious and starts being elegant. It obeys simple rules, and the illusion dissolves into an example of human projection. What felt like a strange behavior of light turns out to be a familiar behavior of the mind. The mirror is honest. It shows exactly what physics allows it to show. The misunderstanding comes from how we interpret what we see. This insight matters beyond mirrors. It reminds us that many obvious features of reality are actually interpretations layered on top of raw sensory data. We do not experience the world directly. We experience a constructed version shaped by evolution, habit, and expectation. Mirrors are just one place where that construction becomes visible. Feynman's explanation is powerful not because it is complicated, but because it strips the problem down to its essentials. He asks us to identify the actual operation being performed and separate it from the story we tell ourselves about it. When we do that, the puzzle disappears. The mirror never reversed left and right. It never needed to. It only reversed front and back, and the rest was us all along. In that sense, the mirror becomes a lesson in scientific thinking. Do not trust the name of the problem. Do not trust intuition alone. Describe what is happening in the simplest possible terms and see where assumptions sneak in. When you do, everyday mysteries often resolve into something far more satisfying than surprise. Understanding. When humans look into a mirror, they do not see a neutral physical transformation. They see themselves. That single fact changes everything. The illusion that mirrors reverse left and right is born not from optics, not from light, and not from geometry, but from the way the human brain recognizes bodies, symmetry, and identity. The mirror becomes confusing only because the observer is human. Human perception is built around the body. From birth, the brain learns the world by mapping it onto a body that has a very specific structure: a clear top and bottom, a clear front and back, and two sides that are almost but not perfectly symmetric. We have 2 eyes, 2 arms, 2 legs, 2 hands, and 2 ears. This bilateral symmetry trains the brain to think in pairs. Left and right become deeply meaningful categories because we constantly use them to control movement and distinguish one side from the other. Front and back, however, are not paired in the same way. We have a face only on one side, eyes that point in one direction, and most of our interaction with the world happens forward. We rarely think of our back as an equal partner to our front. Because of this imbalance, the brain treats front-back as a special axis tied to identity. This is me facing the world. That assumption plays a crucial role when we look into a mirror. When a person stands in front of a mirror, the brain does something automatic and unconscious. It does not think, "I am observing a depth, inverted optical image." Instead, it thinks, "That is another version of me." The mirror image is instantly categorized as a human body with intentions, orientation, and identity. This categorization triggers a comparison. How does that body relate to mine? At this moment, the illusion is born. To compare 2 bodies meaningfully, the brain assumes they are oriented the same way. But the mirror image is not oriented the same way as you in physical space. It is facing the same direction as you, not toward you like another person would. The brain, uncomfortable with this unusual configuration, resolves the confusion by imagining a rotation. It mentally turns the mirror image around so that it can be compared face to face. This imagined rotation is the key step. When a body is rotated 180 degrees around a vertical axis, left and right swap places, but up and down remain unchanged. This is a fundamental property of rotation, not mirrors. The brain performs this rotation instantly, without awareness, and then mistakenly attributes the result to the mirror itself. The mirror becomes the scapegoat for a transformation that happened entirely inside the observer's mind. This is why left and right feel reversed, while up and down do not. Humans never imagine flipping themselves upside down when looking into a mirror. Gravity anchors the vertical axis too strongly. We live our entire lives with a consistent sense of up and down. Our balance, vision, and survival depend on it, so the brain refuses to rotate around that axis. Instead, it chooses the easier and more familiar vertical rotation, which preserves up and down while swapping left and right. The illusion is strengthened by language. We label our hands as left and right, and these labels are deeply tied to motor control. When you raise your right hand, your brain knows exactly which muscles to activate. When you see the mirror image raise what appears to be its left hand, the mismatch feels striking. The brain expects symmetry in identity, not symmetry in physics. It expects me to map cleanly onto me, and when that mapping fails, confusion arises. But notice something important. The mirror image does not label its hands. It is the observer who applies the labels. The image itself contains no information about left or right. It simply shows a body with 2 arms. The sense that the wrong, hand is raised exists only because the observer has a strong internal map of their own body and tries to force that map onto the reflection. This becomes even clearer when you consider written letters on your body. If you write the word left on your left hand and look in a mirror, the text appears reversed. Many people say this proves that the mirror flips left and right, but the reversal happens because the hand itself is being viewed from the opposite direction in depth. You are seeing the back-facing version of the writing, not a left-right flipped version of space. The confusion persists because the brain insists on interpreting the image as if it were a person turned around to face you. Human faces intensify the illusion further. We are extraordinarily sensitive to facial orientation. The brain has specialized regions devoted to recognizing faces and detecting even tiny asymmetries. When you see your face in a mirror, your brain treats it as a social object, almost like another person. This social processing reinforces the urge to compare orientations as if two people were facing each other. Again, this comparison requires an imagined rotation, and again, that rotation swaps left and right. The illusion would be far weaker if humans were shaped differently. Imagine a creature with perfect spherical symmetry, no distinct front or back, and no paired limbs. Such a creature might look into a mirror and experience no sense of reversal at all. The mirror would simply show another version of itself displaced in space. There would be no privileged left or right to be confused about. The illusion depends on the peculiar geometry of the human body. Even within humans, the illusion can be weakened by changing perspective. If you lie on your side and look at a mirror rotated with you, the sense of left-right reversal can become disorienting. If you rotate the mirror horizontally, suddenly up and down can feel reversed instead. The mirror has not changed its physics. Only the observer's frame of reference has shifted. This demonstrates that the perceived reversal is not fixed in the mirror, but flexible in the mind. Children provide another clue. Very young children often struggle with mirrors. They may try to touch the image, talk to it, or move behind the mirror to find the other person. Their brains have not yet fully developed the assumptions needed to create the left-right illusion. As they grow and internalize body symmetry, identity, and orientation, the illusion becomes stable and unquestioned. What feels obvious to adults is actually learned. Cultural factors also play a role. Languages differ in how strongly they emphasize left and right. Some cultures use absolute directions like north and south instead of body, relative directions. Studies suggest that people raised with absolute directional systems experience spatial orientation differently. It is entirely possible that the mirror illusion feels less intuitive in such contexts, further supporting the idea that this is a cognitive phenomenon, not a physical one. The brain's goal is not accuracy, it is usefulness. When interpreting reflections, it chooses the fastest, most socially meaningful model available. Another person like me. That model works well enough for daily life, so the brain never questions it. Physics, however, does question it. Physics strips away identity and asks only what transformation has occurred. When that question is asked, the illusion collapses. Richard Feynman found this explanation delightful because it exposed the gap between how humans think and how nature behaves. Nature does not care about bodies, faces, or handedness. It does not recognize left or right as fundamental categories. Those distinctions live in nervous systems, not in mirrors. The mirror reflects light according to simple rules, and the human brain builds a story on top of those rules. Once this is understood, the mirror becomes less of a trick and more of a diagnostic tool. It reveals how deeply perception depends on internal models. We do not see the world as it is. We see the world as it is useful for a creature shaped like us. The mirror illusion is not a flaw in human perception. It is a byproduct of efficiency. This realization carries a quiet philosophical weight. If something as familiar as a mirror can fool us so completely, what else do we accept without question? How many other features of reality feel obvious only because our brains are built a certain way? The mirror does not lie, but it also does not explain itself. The explanation lives in us. In the end, the reason mirrors seem to reverse left and not up is simple and unsettling. They do neither. The human mind, shaped by symmetry, gravity, identity, and habit, performs a silent rotation and then forgets it ever did so. What we experience is not a property of glass and silver, but a reflection of ourselves. When physicists talk about mirrors, they do not begin with people, faces, or hands. They begin with space itself. Space can be described using directions, and directions can be organized into axes. This way of thinking feels abstract, but it is the cleanest way to understand why mirrors behave the way they do and why up and down remain unchanged while left and right appear to be reversed. The mirror puzzle dissolves once the problem is removed from intuition and placed into coordinates. Imagine space as something that can be measured along three independent directions. One direction goes up and down, another goes left and right, and a third goes forward and backward. These three directions are perpendicular to one another, and together they describe every possible position of an object. Any point in front of you can be located by saying how far it is up or down, how far it is left or right, and how far it is in front of or behind you. This is not philosophy, it is geometry, and it is how physics sees the world. A flat mirror introduces a very specific change to this coordinate system. It does not mix directions, it does not rotate space, it does not swap axes. It performs a single mathematical operation. It reverses the coordinate perpendicular to its surface. If the mirror is standing upright in front of you, the direction perpendicular to its surface is the forward-backward direction. That coordinate changes sign. Everything else stays exactly the same. This is why up and down remain unchanged. The mirror does not touch that axis. There is no physical mechanism by which a vertical mirror could suddenly flip gravity or exchange ceiling and floor. The up-down axis is parallel to the mirror's surface, so it is unaffected. The same is true for left and right. That axis is also parallel to the mirror's surface. Physics treats those directions identically. They are both preserved. The key insight is that mirrors do not care which axis humans find interesting. They care only about orientation relative to the surface. If you placed a mirror flat on the ground and looked down into it, the mirror would reverse up and down, not left and right. Your head would appear below your feet. Gravity would still feel the same to your body, but visually the vertical axis would now be inverted. The mirror did not change its rules, only its orientation did. This single thought experiment exposes the illusion. The mirror does not have a preference for left and right. Humans do. When the mirror is vertical, the depth axis is the one that gets reversed, and humans mentally translate that reversal into left and right through habit and interpretation. When the mirror is horizontal, the depth axis aligns with up and down, and suddenly the illusion shifts. The physics is consistent. Perception is not. In coordinate language, a mirror is not a rotation. This distinction matters deeply. A rotation mixes axes. If you rotate an object 180 degrees around a vertical axis, left and right swap places, while up and down remain fixed. This is a rotation. A mirror does not do this. A mirror performs a reflection, which is a different mathematical operation. Reflection changes the sign of one coordinate without mixing it with others. Because reflections and rotations can sometimes produce similar visual results, the brain confuses them. The brain sees a reflection and interprets it as if a rotation had occurred. This error is subtle but powerful. It leads to the mistaken belief that the mirror itself swapped left and right, when in fact the mirror never performed a rotation at all. In physics, reflections have a special property. They change something called handedness. A coordinate system can be right-handed or left-handed, depending on how its axes are arranged. When a mirror reflects space, it changes the handedness of the coordinate system. This sounds technical, but it has a simple meaning. The reflected world cannot be brought into alignment with the original world using rotations alone. One axis has been flipped in a way that rotations cannot undo. This is why a reflected object and a rotated object are fundamentally different, even if they sometimes look similar. A left glove rotated cannot become a right glove. Only a reflection can do that. The mirror changes the parity of space, not its orientation. Left and right as labels are not what change. The deeper geometric structure does. Up and down survive because their axis remains untouched. Gravity reinforces this stability. Human experience treats the vertical axis as absolute. Buildings, trees, mountains, and bodies all align with gravity. Because this axis is so dominant, the brain never questions it. When the mirror leaves it unchanged, everything feels normal. The illusion hides in plain sight. The left-right axis does not enjoy the same privilege. It is relative, not absolute. If you turn around, your left becomes your right relative to the room. Because this axis is flexible, the brain is comfortable imagining it being swapped. When the mirror reverses depth, the brain chooses the easiest way to reconcile the image with its internal coordinate system. It treats the reflection as if it were a rotated version of reality, rather than a reflected one. This misinterpretation is reinforced by everyday actions. When you shake hands with another person, you extend opposite hands. When you dance facing a partner, movements appear mirrored. Social interaction trains the brain to associate facing someone with left-right opposition. When a mirror presents an image that looks like a person, the brain automatically applies the same social geometry, even though it does not apply. The coordinate explanation cuts through this confusion cleanly. It says, identify the axis perpendicular to the mirror. That axis will be reversed. All others will not. There is no mystery, no special case, no exception. The reason up and down are not reversed is the same reason left and right are not reversed. They are parallel to the mirror's surface. This way of thinking also explains why curved mirrors behave differently. A curved mirror does not simply reverse a single axis. It distorts distances differently at different points. The coordinate transformation becomes more complex, and so does the image. Yet even then, the fundamental rule holds. Reflections operate locally along directions perpendicular to the surface. The power of the coordinate view is that it removes the human body entirely from the explanation. The mirror would behave the same way if no humans existed. It would behave the same way for cameras, sensors, or hypothetical beings with no sense of left or right. The laws of reflection are indifferent to perception. They are geometric. Richard Feynman loved explanations like this because they show how easily humans mistake description for explanation. Saying the mirror flips left and right is a description of an experience, not an account of what happened. Physics demands the latter. It asks which coordinate changed and why. When that question is answered, the experience becomes understandable rather than mysterious. Once you adopt this viewpoint, mirrors stop being puzzling and start being predictable. You can place a mirror at any angle and immediately know which directions will be reversed by identifying the perpendicular axis. You no longer need intuition or analogy. Geometry does the work. The deeper lesson is that reality does not align itself with human categories. Left, right, up, and down feel fundamental because our bodies are built around them. But physics does not recognize these labels. It recognizes relationships, orientations, and transformations. When those are understood, the illusion disappears. Up and down stay unchanged not because mirrors respect gravity or because the universe prefers vertical stability, but because of a simple geometric fact: that axis is not the one being reflected. The mirror does not choose sides. It reflects space according to its surface, and everything else is interpretation layered on top. In this sense, the mirror question becomes a lesson in scientific humility. What feels obvious is often the result of unconscious translation. We translate geometry into bodily experience, then forget that the translation occurred. Feynman's answer reminds us to step back and ask what transformation actually took place, independent of how it feels. When that step is taken, the mirror no longer appears to reverse left and not up. It reverses exactly one direction every time without exception. The rest of the confusion belongs not to glass and light, but to the way humans map space inside their minds. Richard Feynman approached the mirror question in a way that was very different from how most people instinctively think about it. He did not begin with human confusion, visual tricks, or psychological interpretation. He began with physics. For Feynman, the goal was never to comfort intuition, but to expose where intuition quietly cheats. The mirror problem was interesting to him not because it was mysterious, but because people were so confidently wrong about it. From a physicist's point of view, a mirror is an object that redirects light according to precise laws. Light rays strike the surface and reflect in a predictable way. There is no awareness, no preference, no special treatment of directions. The mirror does not know what left or right means. It does not know what a human is. It does not even know that it is creating an image. All it does is obey geometry. Feynman insisted that any explanation that starts anywhere else is already on shaky ground. He often warned against explanations that rely too heavily on humans, entered thinking. When people say the mirror reverses left but not up, they are describing a human experience, not a physical process. Feynman's instinct was to strip the problem of human language and rebuild it using the bare minimum: space, directions, and transformations. Once that is done, the confusion evaporates. In physics, there is no such thing as an absolute left or right. These are labels invented by humans to navigate their environment. The universe itself does not tag directions with names. It only allows relationships between points in space. When a mirror reflects an object, the only thing that changes is the relationship along one spatial direction. Everything else remains untouched. This is not an opinion, it is measurable. Feynman would point out that if mirrors truly reversed left and right as a physical law, the consequences would be dramatic and unavoidable. Instruments would malfunction. Mechanical systems relying on symmetry would behave strangely, but none of that happens. Mirrors are used in laboratories, telescopes, lasers, and spacecraft with absolute confidence. Engineers do not worry about mirrors secretly swapping directions. The laws of reflection are too well understood for that. What bothered Feynman was not that people were confused, but that they stopped questioning once a familiar phrase sounded reasonable. Mirrors reverse left and right feels true because it matches experience, but physics does not care how something feels. It cares how it behaves. The role of science, in Feynman's view, is to keep asking what is actually happening, even when the answer threatens comfortable intuition. He often emphasized that nature is under no obligation to make sense to us. When intuition conflicts with experiment or geometry, intuition must yield. In the mirror case, intuition tells us one thing, while geometry tells us another. Feynman trusted geometry. He trusted the rules that work whether or not a human is present to observe them. This is why he framed the mirror explanation in terms of coordinate systems and transformations rather than perception. A mirror reverses one coordinate. That statement is complete. It requires no reference to people, bodies, or brains. It is true in empty space. Everything else people add to the explanation is an attempt to reconcile this cold fact with warm human experience. Feynman had a deep respect for simplicity, but not for oversimplification. Saying the mirror flips front and back may sound trivial, but it is precisely correct. Saying the mirror flips left and right is emotionally satisfying but physically false. To Feynman, the difference mattered enormously. Precision in language was not pedantry, it was honesty. He also understood that humans are storytelling creatures. We prefer explanations that involve familiar objects like hands, faces, and movements. But Feynman believed that real understanding often begins when those stories are set aside. The mirror problem becomes difficult only when we insist on placing ourselves inside it. When we remove ourselves, the mirror behaves exactly as expected. This attitude reflects a larger theme in Feynman's thinking. Physics is not about what we think the world should do, but about what it actually does. The job of the physicist is to notice where intuition breaks and to learn from that break. The mirror illusion is valuable precisely because it reveals a crack between perception and reality. Feynman often used everyday examples to teach this lesson. He liked problems that seemed simple but exposed deep misunderstandings. The mirror question fits perfectly into this category. Almost everyone has an answer ready, and almost everyone's answer is wrong. That makes it an ideal teaching tool, not about mirrors, but about thinking. From Feynman's perspective, psychology may explain why people feel confused, but it does not explain the mirror. Physics explains the mirror. Psychology explains the confusion. Mixing the two leads to vague explanations that satisfy neither field. Feynman preferred to keep the boundary clear. First, describe what the mirror does. Then, separately, ask why humans misinterpret it. This separation is crucial. Many explanations blur the line, saying things like the mirror flips depth, and our brain interprets that as left-right reversal. Feynman would push harder. He would say, the mirror flips depth, period. The rest is a different question. That discipline prevents the explanation from drifting into metaphor and losing its grounding. He was particularly skeptical of explanations that rely on phrases like "it looks like" or "it feels like." Those phrases signal the presence of perception, not physics. Feynman valued explanations that would still make sense to a camera, a robot, or an alien intelligence. A mirror would behave the same way in all those cases. That universality is the hallmark of a physical explanation. The mirror problem also touches on a deeper issue Feynman cared about: symmetry and asymmetry in nature. Physics often studies what happens when symmetries are preserved or broken. A mirror breaks a certain symmetry by reversing one spatial direction. Understanding exactly which symmetry is broken and which are preserved is far more important than naming which human labels appear swapped. Up and down remain unchanged not because mirrors respect gravity, but because the mirror's surface does not interact with that axis. That fact is independent of human orientation. Feynman would insist on that independence. The explanation must stand even if gravity did not exist, even if humans did not exist. In this way, Feynman's answer is almost deliberately unsatisfying to casual intuition. It does not dramatize the mirror. It does not anthropomorphize it. It quietly states the rule and moves on. The drama appears only when we realize how wrong our initial assumptions were. This approach reflects Feynman's broader philosophy of science education. He believed that students should not be protected from confusion, but guided through it. The mirror problem teaches that confusion is often self-inflicted. We ask the wrong question and then marvel at the strange answer. The wrong question is, why does the mirror reverse left and not up? The right question is, what transformation does a mirror perform? Once that question is asked, the answer is straightforward. The original mystery vanishes, replaced by a clearer understanding of both mirrors and ourselves. Feynman's explanation ultimately shifts responsibility away from the mirror and back onto the observer. The mirror is innocent. It follows the laws of reflection perfectly. The error lies in the assumptions humans bring to the act of looking. This reversal of blame is characteristic of Feynman's style. He enjoyed showing that nature is simpler than we think, and that our minds are the complicated part. By refusing to rely on psychology, Feynman did not dismiss it. He simply refused to let it masquerade as physics. He knew that mixing explanation levels creates comforting stories but weak understanding. His mirror answer remains powerful because it is clean, disciplined, and unapologetically physical. In the end, Feynman's perspective teaches something larger than how mirrors work. It teaches how to think. Separate what happens from how it feels. Identify the transformation. Question familiar language. Do not assume nature shares human categories. When those habits are practiced, not only does the mirror stop being mysterious, but many other everyday puzzles begin to look different as well. The mirror never chose left over up. Physics never made that distinction. That distinction lies in human interpretation. Feynman's gift was showing that once you remove the human-centered story, the universe quietly explains itself without confusion and without apology. The mirror question feels small at first, almost playful, yet it opens a door to something much larger. The realization that understanding the world is never just about what is out there, but also about how we think. The idea that mirrors reverse left but not up survives not because it is correct, but because it fits comfortably inside assumptions we rarely examine. The mirror becomes a quiet test of how deeply those assumptions run. Every time a person looks into a mirror, they believe they are seeing reality directly. The glass seems honest. It reflects light faithfully, without distortion, without commentary. Because the image looks familiar, the mind relaxes. It does not question. This sense of familiarity is exactly what makes the illusion powerful. When something feels obvious, the brain treats it as settled truth, not as a hypothesis worth testing. The assumption that left and right are being reversed slips in unnoticed. It feels natural because left and right are deeply personal directions. They are learned early in life and reinforced every day through movement, language, and habit. We learn to write with one hand, greet with another, turn left or right on command. These directions are tied to identity and action. When something seems to interfere with them, we react strongly. Up and down, by contrast, feel different. They are not personal in the same way. They are imposed on us by the world. Gravity decides what is up and what is down, not choice or habit. Because of this, we rarely imagine them being negotiable. They feel absolute. This difference in how we experience directions quietly shapes how we interpret the mirror. The mirror itself does nothing to encourage these assumptions. It reflects light without caring about labels. Yet the mind cannot help but add a story. It sees a human shape and instantly activates a whole network of meanings: front, back, face, hands, identity. The reflection is no longer just an image, it becomes me. And once that happens, the brain insists on interpreting the image using the same rules it uses to understand other people. Here is where assumptions do their most subtle work. We assume that to compare two people, they must be facing each other. That assumption is so ingrained that we rarely notice it. When we meet someone, we stand face to face. When we talk, we orient ourselves accordingly. When we imagine another person, we imagine them turned toward us. The mirror image violates this expectation, but instead of questioning the expectation, the brain adjusts the image. That adjustment takes the form of an imagined rotation. Without conscious effort, the brain turns the mirror image around so it can be treated like another person. Once that imagined rotation is in place, left and right swap. The mind then reports the result as something the mirror has done, rather than something it has assumed. The conclusion feels obvious because the assumption was invisible. This is the deeper lesson hidden inside the mirror puzzle. We rarely distinguish between what we see and how we interpret what we see. The two feel fused together. Yet they are not. The mirror provides raw sensory information. The brain supplies meaning. When meaning is supplied automatically, it becomes indistinguishable from perception itself. Richard Feynman was fascinated by this gap. He understood that many misunderstandings in science come not from lack of intelligence, but from unexamined assumptions. People are not wrong because they are careless. They are wrong because they are confident. Confidence discourages curiosity. The mirror problem persists because most people feel they already know the answer. What makes this especially striking is that the correct explanation does not require advanced mathematics or exotic theory. It requires subtraction rather than addition. You remove assumptions instead of adding complexity. You stop asking what the mirror seems to do and ask what it actually does. When you do that, the illusion fades. This pattern repeats across science. Humans tend to project their own categories onto the universe. We assume nature shares our intuitions about time, space, causality, and direction. Sometimes those intuitions align with reality. Often they do not. Mirrors offer a gentle example of this mismatch, but the same principle appears in far more serious contexts, from quantum mechanics to cosmology. The danger of assumptions is not that they exist. They are unavoidable. The danger is that they hide. When an assumption remains invisible, it cannot be questioned. The mirror makes an assumption visible by producing a result that feels strange. That strangeness is an invitation to examine what we took for granted. Consider how language reinforces the illusion. The phrase mirror image itself suggests duplication rather than transformation. Words like flip and reverse imply rotation or swapping, not reflection. Once these words are learned, they shape how the experience is framed. The brain reaches for familiar language, and the language quietly shapes thought in return. Education often strengthens this effect unintentionally. Children are taught early that mirrors reverse left and right. The statement is easy to remember and easy to demonstrate superficially. Rarely is it challenged. Once learned, it becomes part of the mental furniture, something that feels too basic to question. The assumption hardens with age. The mirror problem shows how fragile that certainty really is. A single careful question, what exactly is being reversed, is enough to expose the flaw. Yet that question is rarely asked, because certainty suppresses curiosity. Feynman believed that the willingness to ask such questions, even about obvious things, is the core of scientific thinking. This willingness requires humility. It requires accepting that feeling certain does not mean being correct. Mirrors feel simple. That is precisely why they are effective teachers. They show that misunderstanding does not always wear the costume of confusion. Sometimes it wears the costume of familiarity. The illusion also reveals something about how humans understand themselves. We tend to think of identity as something fixed and centered. The mirror disrupts that sense slightly, enough to cause discomfort, but not enough to trigger alarm. The mind resolves the discomfort by imposing a familiar structure. It chooses comfort over accuracy. Once this pattern is recognized, it becomes easier to spot elsewhere. How often do we explain complex phenomena by fitting them into familiar narratives rather than examining them on their own terms? How often do we assume that because something looks a certain way, it must work a certain way? The mirror quietly asks these questions without demanding an answer. Feynman's answer is amazing, not because it is clever, but because it is honest. It refuses to flatter intuition. It does not rescue the illusion, it dismantles it. In doing so, it offers a kind of intellectual freedom. You are no longer trapped by how things seem. You are free to ask how they actually behave. This freedom comes with responsibility. Once you see how assumptions shape understanding, you cannot unsee it. You begin to notice how often explanations rely on words rather than mechanisms, on comfort rather than clarity. The mirror becomes a symbol of a larger discipline, the discipline of separating observation from interpretation. The mirror itself is passive. It does not argue. It does not explain. It simply reflects. The work of understanding happens entirely in the observer. This is both humbling and empowering. It means that confusion is not a failure of the world, but an opportunity for the mind to grow more precise. In the end, the mirror teaches a lesson far more valuable than the answer to a clever question. It teaches that understanding is an active process. It requires effort, skepticism, and the courage to question what feels obvious. The world does not announce where our assumptions end and reality begins. That boundary must be discovered. Mirrors do not reverse left and not up. They reflect space in a simple, consistent way. The belief that they do otherwise survives because it fits comfortably inside human habits of thought. When those habits are examined, the illusion dissolves, leaving behind something quieter but more powerful, a clearer view of both the mirror and the mind looking into it. And perhaps that is why the question endures. It is not really about mirrors at all. It is about how easily we mistake our interpretations for facts, and how much understanding waits on the other side of a single, well-laced doubt.